Hello, how you doing? It's Mr. Mrdothemath here, and today we're going to talk about area, or more specifically the area of parallelograms. All right. Before we talk about the area of parallelograms, let's talk about these other four-sided shapes that you're going to look at that we know about. Let's look at the area of a rectangle. All right. A rectangle is a four-sided shape that has two sets of congruent sides, and they make 90-degree angles, right? The area is going to be base times height, 5 the length times the width, right? Then you got this thing here, which is square. The square is like a rectangle, except all of its sides are the same, right? Since all the sides are equal, one common way to find the area of a square is just side squared. Or you can do base times height, which is side squared equal, okay? Now, parallelogram. It is a four-sided figure, but as opposed to these two, there's not 90-degree angles involved, right? You do have congruent sides, but you don't have 90-degree angles. However, because it's four-sided, the area of a parallelogram is going to be base times height, okay? But your height usually is not visible, right? Your height is going to be like an altitude, right? So sometimes your height is going to be here, or your height will be given to you on the outside. All right. So this is where your height is in a parallelogram. Okay. So let's take a look at some practice. Let's practice. So what if I got this parallelogram here? So bop, bop, bop. This is 20. This is 30. What would the area be? I don't know yet, because I don't have the height. So I need to know what the height is. So what if they said the height was 17? You say it was 17? Yeah. Now that we know what the height is, we can calculate it. It'll be essentially 30 base times height, 17, right? 30 times 17. And that's how you get your height being 510 units squared. Okay. What about the perimeter? Well, the perimeter is the distance around. Perimeter is always the distance around. So essentially what you do is you add all the sides together. So if this is 30, this is also 30, and this is 20, right? So the perimeter is going to be 20 plus 20 and 30 plus 30. So it'd be 2 times 20 plus 30. All right. So 20 plus 20, well 20 plus 30 is 50. 50 squared is 100. So the perimeter is going to be 100 units. Okay. And that's the parallelogram. What did you notice here? If you look at a parallelogram, what you see is a triangle here. So let's talk about the area of a triangle. Area of a triangle is essentially half of the area of a four-sided figure. So the area is going to be base times height over 2. Base times height over 2. Now, when you have a triangle, almost somewhat like a parallelogram, you need two things. You need the base, which is usually this one, and these are just sides. Those are just sides. Those are not the height. The height is going to be found sometimes in the middle or going through one of the vertices. So this is the height, right? So that's what you need. You need this and you need this. All right. So let's look at an example over here. All right, we got this triangle here. 17. This is 10, and this is 21. What is the area? Well, we don't know because you need the height. So we draw this here, and they're gonna tell us that the height is 8. Now, what's the area? That's easy now. The area is gonna be base times height over 2. All right? So this is our base, this is our height, these are just other sides. Okay? So that's gonna be, and so what I usually do is, if either the base or the height is like an even number, I can just divide this 2 already. And so since 8 is even, I can change it to 21 times 4. 21 times 4 is like, it's less operations to do, and you get 84. So 84 is the area. What about the perimeter? The perimeter is the same as the perimeter is for a parallelogram. It's just the distance around. So you're just gonna add 21 plus 10 plus 17. So the perimeter is gonna be 21 plus 10 plus 17. All right, 21 plus 10. 21 plus 10 is 31. 31 plus 17, 48. 48 units. This is units squared. So that's your perimeter. All right. So for some of us, for many of us, it's gonna be a review all of this. All right. Let's look at another example of a triangle. Okay. What if I have this triangle here? Bop, bop, bop. And this is a right triangle. This is 5. This is 13. They want to know what the area is. Well, I can't tell you what the area is yet because I need to know what the base is. Now, I do have the height. This is just the hypotenuse, right? Woo-hoo. We need the height. So first things first, we need to find out what the height is. So in order to calculate this distance, we have to use Pythagorean theorem. Equals c squared, right? This is C, this is A or B, this is B or A, right? So we'll do 5 squared plus B squared equals 13 squared, which is 25 plus B squared equals 169. Subtract 25 from both sides, you're gonna get B squared equals 144, right? So B is 12. So this is 12. All right, good. So now we got the base and we got the height. Now we can do the math. So the area is gonna be height times base over 2. Again, like we did back here, we can find an even. There's an even number up here. It's 12 is even, so we can just do this math here. That'll make it 6, so it'll be 5 times 6 to give us an area of 30 units squared. Okay? So that's the area it's the area of a four-sided figure. So we got rectangles, squares, we got a parallelogram. That's, oh yeah, we didn't even talk about why is it parallelogram? Parallelogram because it's a polygon with 2 pairs of parallel lines. Those are parallel, these are parallel, right? And then we got a triangle. Now let's give you a harder situation, a more challenging situation. I won't say harder, a more challenging situation. All right, what if I got this figure here? It looks like this: bop, 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 right? And so in here you got this situation, you got this. That's the parallel part. This is the other parallel part. And then I told us the height is 13. So this is the height. This is 18, this is 9, and this is 11. They want to know the area of the whole thing, right? They want to know the area of the whole thing. All right, the first thing you want to do is separate all of your shapes. You want to separate all of your shapes. All right, so number 1, separate the shapes. All right, so we got a triangle, bop, parallelogram, bop, and another triangle, bop. All right, then the next thing you want to do is you want to find missing pieces. Well, if we label everything we got a 9 here, that's the base. This is 18, so the bottom's gonna be 18, and then this is 11, okay? Now, to find the area for all of these, we got, for this triangle, we got base times height over 2. For this parallelogram, we got base times height. And then for this one, we got base times height over 2 again. All right? So we got our bases. Check, check, check. And we have our heights. It's 13. It's going to be 13 for this one, and it's going to be 13 for this one. So the height's 13, the height's 13, and the height is 13. Right? So oftentimes with some triangles, depending on how they're situated, the height is going to be provided on the outside of the shape. All right? So now we have all of our missing parts. The next thing we want to do is find an area. All right, so we're gonna find the area. So this is gonna be 9 times 13 over 2. This is gonna be 18 times 13, and then this is gonna be 11 times 13 over 2. All right, and you're gonna add all of those areas together. All right, I need my calculator. So we can do the math. All right, let's do the math. So we got 9 times 13, 117 over 2. We got 18 times 13, we get 234, and then we got 11 times 13, which is 143 over 2. All right, let's add all those together. So it's 117 over 2 plus 58.5 plus 234 plus 143 over 2, and we're going to get 364 units squared, right? So again, when you have a figure that has multiple shapes that make it up, first thing you want to do is you want to separate the shapes like we did here, right? Then you want to find the missing parts, or label your parts. You got your for the area of each shape, you need a base and a height. Find the area and then add them all together. All right. So that's pretty much area of parallelograms, squares. Well, we didn't do no squares, but parallelograms and triangles for the most part. All right. So remember to list what it is, what the area is, the area formula, and then find the parts that satisfy the formula. All right. If you have any more questions, comment below. Don't forget to like and subscribe. Just do the math.